Hi everyone, my name is Billy and I'm going to present the work entitled Synthesis of Glutaraldehyde cross-link ketone hydrogels for absorption of heavy metals in aqueous solution. Currently, there is a focus on improving water quality to minimize the impacts on ecosystems and human health. Heavy metals are elements with many industrial applications, but they are highly toxic even at low concentration. So, removing them from water is very important. The absorption is a useful process for removing these elements from water, and the ketosane has demonstrated a high absorption capacity. So its use will be discussed later. For methodology in hydrogel synthesis, the ketosane was first weighed and dissolved in acetic acid. Glutaraldehyde was then added for cross-linking, and the resulting solution was centrifuged to sediment the suspended particles. Finally, the solution was added to petri dishes and allowed to dry at room temperature. The hydrogel was characterized by X-ray and infrared spectroscopy to determine the crystalline structure of the material and the functional growth present in the surface. Finally, the absorption isotherms and a known amount of mercury, nickel, and copper was weighed at pH 4, and a variable mass of the hydrogel was added. The solution was stirred for 24 hours at 40 degrees Celsius and quantified by atomic absorption spectroscopy. And this equation was used to obtain the absorption capacities. In result, the figure 5 shows a membrane of pure ketosane and cross-link ketosane with glutaraldehyde. Color change is observed due to an amine catalyzed aldol addition. The figure 6 shows the infrared image of pure and cross-linked ketosane. The most notable aspect of this analysis is in the section B, where an increase in peak intensity, this peak, is observed. This is attributed to the presence of imine groups, which are formed by the cross-linking between the ketosane and glutaraldehyde. The cross-linking is important because it modifies some characteristic of the ketosane. For example, giving it greater thermostability and preventing it from dissolving in acidic media. The figure 7 shows the diffraction pattern of the materials. In A, the figure A, the peaks at 10, 13, and 20 degrees indicate high crystallinity due to the ordered structure of ketosane. In B, the peaks at 13 degrees disappear and the peak at 10 decrease in intensity due to the formation of an amorphous structure after cross-linking. And finally, the figure 8 shows the absorption isotherms, which obtain values of 0.560 millimole per gram for mercury. In B is for copper 0.144 millimole per gram and 0.016 millimole per gram for nickel. And in conclusion, higher absorption capacity was obtained with mercury, followed by copper, and finally nickel. The ketosane hydrogel was regenerated for use in new absorption rounds, making it a suitable material for its application. Thank you.